In this chapter, we'll be talking about consumer problems, and consumer problems will illustrate how the arithmetic we've been learning is used in everyday life. Now, in this section, we're talking about unit price or unit cost. And the unit cost idea is related to something we studied before. You may recall that we talked about unit rate. And an example would be that we might travel a certain distance in an automobile, and then we fill up with gas, and we fill it up with, let's say 15 gallons of gas. Well, what is our mileage? That is, how many miles per gallon are we getting? Well, we take the total number of miles and we divide by the number of gallons, and we have that miles per gallon idea. Well, unit pricing or unit cost is somewhat the same. It is the cost per unit. Cost per unit. And the per idea, remember, refers to division. So we're going to take a cost and we're going to divide by some number of units. Consider this problem. If 3 shirts cost $36, what is the cost per shirt? What is the cost per shirt? Well, cost per shirt gives us an idea of what we need to do. It's the cost divided by the number of shirts. So the cost per shirt idea can be thought of like this: cost per shirt. And filling in, it is $36 divided by 3, and 36 divided by 3 turns out to be 12. So $12 is the cost per shirt. Here's another one. A herd of 25 cattle costs $25,000. What is the cost per cow? Now notice, cost per cow. So we're going to take that total cost and divide by the number of cows. So it's cost $25,000 divided by the number of cows. There are 25 of them, and that's all we have to do. Now, another way to look at it, another way to illustrate it or write it would be like this. We could say this is $25,000 divided by 25. You see, so either way you look at it is fine. And once we go through the division process, we find that each cow costs $1,000. Here's another one. Now this is a grocery store problem. This is one where we're trying to figure out a better deal. And we see on the shelf that there are cans of, there are packages of potato chips. There's an 8-ounce package and a 10-ounce package. But 8 ounces cost 99 cents. 10 ounces cost $1.23. What's the better deal? Well, in grocery stores, sometimes they have the unit price written with the item on a little price tag it's kind of a shelf tag. So you'll see this calculation already made, but here's how the calculation is accomplished. It is, let's see, 8 ounces cost 99 cents. Now, we're trying to find the cost per ounce, and we might make a note of that. It's cost per ounce that we're after, and so we have a division implied here. We're going to take a price, the amount of money, and we're going to divide by the number of ounces. So for the 8-ounce, I'm going to just make a note like this. For the 8-ounce package, it is, let's see, cost per ounce, well, that would be 99 cents divided by 8. You see, and once the division is accomplished, and we're not going to go through that part, but we can use the calculator or we can do it by hand, but we'll find out that it is 0.12375. Now, this is some amount of money, but in money, in dollars and cents, we only have 2 digits to the right of the decimal point. If we round it off to that position, it would be 12 cents per ounce, you see, because we would round off and just kick out these the digits to the right of the 2. But let's leave it as this value. This is a more exact amount as the cost per ounce. Let's just leave it like that for comparative purposes for right now. Now, the 10-ounce package tells us that, let's see, cost per ounce. The cost is $1.23, and we're dividing by the number of ounces, that's 10, And dividing by 10, remember, means that we just slide this decimal 1 to the left. So this becomes 0.123. And that's it. Now, which one costs less? You see, now they're very close, very, very close as a matter of fact. They are the same for the tenths digit. They are the same for the hundredths digit, the same for the thousandths digit. But this one has no 10,000s, and this has 7 10,000s. So the 10-ounce package contains potato chips that are less per ounce, a little bit less per ounce. All right, so that's the idea. We find cost per ounce for each package. Now, here's a situation where we're kind of going in reverse of that of our idea of unit pricing. We have the unit price in this problem, and we want to find a total cost. Let's see how that's done. Pine saplings are $4.96 each. How much would 7 pine saplings cost? You see, we have the cost of every one of those little trees, and we want to know how much 7 of them will cost. A lot of times, material in stores is priced this way. You have a certain amount of money for each one, and then you want to buy so many of them. Well, how do you figure out your total cost? Well, you take the unit cost, the cost for each one of those items, and you multiply by the number of items you're buying, and that'll give you the total cost. Now, you don't need to memorize this as a formula. You just use it as an intuitive idea. We're talking about a unit cost per tree of $4.96. So we take $4.96 and multiply times the number of items that cost that much that we're buying. So we're multiplying by 7, and we find that to be $34.72 as the total cost of the little trees. In this problem, we're given the unit price of cheese. It says cheese costs $2.89 per pound. And then we're asked to find a couple of things, to make a couple of calculations. The first item, find the cost of 2 pounds. Well, we know that fundamentally to find a total cost, what we do is we take the cost per unit and we multiply by the number of units we have, and the product will be our total cost. Now, in this problem, the kind of unit is called a pound, so we could modify our items here and write cost per pound times number of pounds to give total cost. Well, that's what we understand, and we may or may not write this down before we begin our calculations. To do the calculating, we write down the cost per pound, $2.89, and for the A part of the problem, we multiply by 2. And 2 times $2.89 is $5.78, so 2 pounds of cheese will cost $5.78. Now, the reason I put this problem into the mix is because of the B part. It says find the cost of 65 hundredths pounds of cheese. You see, usually we have problems in this arena where we're given some whole number of pounds. Well, it doesn't make any difference whether you're given a part of a pound or some whole number of pounds or some mixed number of pounds. It really doesn't make any difference. The idea is exactly the same. You take the cost per pound, in this case $2.89, you multiply by the number of pounds, in this case it's a part of a pound, and upon multiplying we get some amount. Now notice it's 1.8785. Well, we're talking dollars and cents here, so we need to round to the nearest penny, and that means it's $1.88. So 0.65 or 65 hundredths pounds of cheese costs $1.88.